So here's another conceptual problem for you. Again, don't use a calculator, just let's think about it conceptually, not just focusing on what's the equation. So if you throw a baseball straight up and it leaves your hand at 15 meters per second, how long does it take to reach its maximum height? And what is that maximum height? So two questions. How long does it take to reach its maximum height? And how high is that? So that's what we've got. We are going to start with a picture, as we always do. So my beautiful art skills, we have tossing straight up a baseball. And it's going to go up and then it's going to come down. And we want to know how long it takes to reach its maximum height. So question is how long it takes to reach maximum height and what is the maximum height? So the max height is what? All right, and what did we know? We knew we tossed it straight upwards at 15 meters per second. Okay, and again for this one, because we're not using a calculator, I'm just going to say that the acceleration due to gravity is, we're going to use 10 instead of 9.8 squared. That'll make our calculating life much easier. Let's see, what do we do? Okay, we want to know how much time it takes to reach its maximum height. So we've tossed something straight up in the air, so we're just going up, and we want to know how much time it takes to get to this maximum height. Well, if you remember the idea of this turning point at its maximum height, what is its velocity? Its velocity is going to be 0. It's briefly stopped. We have a positive velocity, 0, and then a negative velocity as we go down. So we do know that at the maximum height, different color, the velocity is 0. We're starting at 15 meters per second, and we want to know how much time it takes us to go to velocity 0. All right, we're slowing down because of gravity at 10 meters per second squared. So we drop 10 meters per second in velocity every second. So if we think about this way, at time 0, we are moving upwards at 15 meters per second. So 1 second later, the definition of acceleration means that if our acceleration due to gravity is downwards at 10, I should have that downward, we've lost 10 meters per second in speed in 1 second, which means we were at 15 upwards, now we're at 5 upwards. All right, let's go for 2 seconds. 2 seconds. What is our velocity at 2 seconds? Well, again, because our acceleration is 10 meters per second, every second, downwards, we've lost, in this second from here to here, we've lost another 10 in speed. So from 5 upwards, we're going 5 downwards. 5 minus 10 is negative 5. All right, so that means that the time it takes to reach the turning point is somewhere in between these two. And looking at the symmetry of this, I'm going to say we're right in the middle. The time it takes is going to be 1.5 seconds. Because if we were at plus 5 at 1 second, minus 5 at 2 seconds, we're talking about 1.5 seconds to reach that midpoint. So 1.5 seconds to reach its maximum height, is that reasonable? 15 meters per second, well, how fast is that? Again, to convert it to miles per hour, double plus a little bit, so 30 plus a little bit, maybe 30, 33, 35 miles per hour. Pretty fast. I mean, it's not a baseball pitch, but that's pretty fast, so I would think it would take some time. Yeah, this thing, it doesn't even take probably half a second to reach its maximum height. But for 33, 35 miles an hour, I would say 1.5 seconds is reasonable. So I think that's reasonable. Time, 1.5 seconds. What is that maximum height? So how high did it go? All right, and here I'm going to go back to the equation we used in the previous video and say, let's use our long equation. So we have x final equals x initial plus v initial t plus 1/2 a t squared. So what do we have that's 0 here? Well, let's set this to be x equals 0. Let's set our position to be 0 when it leaves our hand. So that's when it leaves my hand, that's my origin. That means my initial position is 0. Now in the last one where we just dropped something, we also had initial velocity as 0. Do we have that in this case? Can we say initial velocity is 0? Nope, we can't. Because we're throwing this thing, we're not dropping, we're throwing. So initial velocity, that's a positive 15 meters per second, okay? So we've got that. And 1/2, my acceleration is 10, we're just using that as a rounding. But again, downward, -10 t squared. So my final position ends up being 15t, and that ends up being -5t squared. Don't grab your calculator, see if you can do it without the calculator. All right, let's do the same thing. 0, 1, 2, and let's see what we get at 1.5 as well. At time 0, my position is 0 because that's what we decided. At time 1, what is my position? 1 second. Okay, so 1 second, we have 15 times 1, okay, 15, minus 5 times 1 squared, -5. My final position here is 10 meters. That's pretty high, 30 feet. Well, but again, we're tossing this upward at about 33 miles an hour. All right, so 2 seconds. Where's this thing at 2 seconds? Now I want you to stop here and predict. Is it going to be at its maximum height? Is it going to be somewhere else? Is it going to be, yeah, I don't know. Where do you think it's going to be at 2 seconds? I'm going to give you a hint. Think about this. Pause if you need to. Where do you think it's going to be at 2 seconds? Okay, let's give it a try. 2 seconds, what do we have here? 15 times 2, we have 30, minus 5 times 2 squared. 5 times 4 is 20, minus 20, x final equals 10. Did you get that? Did you predict that? I hope you did. This is one of the beautiful things, the symmetry of this kind of motion is it takes exactly the same amount of time to go up as it takes to go down to that same point. It's going as fast as it was going up as it is when it's coming down at that same height or at that same time. That's one of the really cool things about just this motion, this consistency of acceleration. If you have a constant acceleration, you've got this beautiful symmetry that helps you figure stuff out. So at 1 second, we were moving upwards at 5 meters, and we were 5 meters per second, excuse me, and we were at 10 meters above the ground, or above where we set. At 2 seconds, we were moving downwards at 5 meters per second, and we were, again, 10 meters above where we tossed it. So let's figure out where its maximum height is. Let's do this 1.5 seconds thing. And now you're saying, I can't do this without a calculator. You can. You can. All right. So 1.5 seconds, we're going to pop it in here. So 15 times 1.5 minus 5 times 1.5 squared. Okay, 15 times 1.5. Well, 15 times 1 is 15. 15 times 0.5. 15, a half of 15 is 7.5. So that part is 15 plus 7.5. That is 22.5. Minus 5 times 1.5 squared. All right, and so let's see. It's between 1 and 2, so 1.5 squared is between 1 squared and 2 squared. So it's got to be between 1 squared, which is 1, and 2 squared, which is 4. So my answer has to be between 1 and 4. And what I tend to do with this is I say, well, to heck with the decimal point, what would 15 squared be? And 15 squared is 225. So where would the decimal point need to be to get between these two? Well, 225 would be 2.25. 2 1/4. If you want to convert this to fractions, if you'd be more comfortable with the fractions, go ahead and do it like that. So we got this part done. Now we want 5 times 2.25. Well, 5 times 2 is 10, plus 5 times 1/4. Oh my gosh. 5 times 1/4 is 5/4, which is 1.25. All right, 22.5 minus, that's 11.25. Okay, 22.5 minus 11.25. X final is, oh, look at that, that's doubled. Again, this weird symmetry. It's all the way up and all the way down, and we've got this half again. 22.5 is double that. So, maximum is 11.25 meters. That's our maximum height. So that's the second one. Is a reasonable number. Well, okay, 11.25 meters is, I don't know, like 12 yards, about 35 feet. Well, I would say that's actually reasonable. It's not much more than what we had here. So by the time it went 1 second, it was almost all the way to the top, which should make sense to you because it's moving fast for that first second, and then it's pretty slow by the time it's going here. So it's almost stopping, and then again that next second where it's from 0 to well, okay, the next second from 1.5 onwards, it's slowly speeding up and then speeding up. So I think this is reasonable given all the answers we had. So we answered the question, we didn't use a calculator, we thought about what velocity means and acceleration means, and we figured out the time it takes to reach maximum height and our maximum height. It's all reasonable. That's what we got. Good job.